Hey, it's Mr. Shrum, and welcome back to a tutorial, a physiology tutorial. And we're going to look at energy systems today. And these systems are used to provide our bodies with energy during exercise. And it's used to fuel biological processes. And this comes from the breakdown of ATP, adenosine triphosphate. There is chemical energy stored in the bonds of an ATP molecule. When work such as a muscle contraction is performed, the bond between the last two phosphates in this structure, they break. And this produces adenosine diphosphate, which is ADP, and then a separate phosphate molecule that has broken off of the original ATP, and then useful energy, which is used to perform the work as well as heat. So you have ATP, this big ATP molecule. One phosphate breaks off, and then that results in energy and heat. There is a small amount of ATP stored in skeletal muscles. This stored amount of ATP can fuel approximately 5 to 10 seconds of high intensity work. Therefore, in order for work to continue, ATP must continuously be synthesized. And there are three main energy sources that are responsible for the synthesis of ATP. We have the ATP PC system, that's anaerobic, so no oxygen is actually required for that. Anaerobic glycolysis, that's the lactic acid system. And then the oxygen system, and that's aerobic, meaning we need oxygen for that system to work. The energy systems can be described in terms of their power and duration to produce ATP. Power refers to the rate at which ATP can be produced. Duration refers to how long the system can continue to produce ATP. Two important characteristics about fuel utilization during exercise should be kept in mind. All of the energy producing systems are active during most exercise sessions. Yet, different types of exercise place greater demands on different energy systems. For example, middle distance events, and middle distance is considered about 1,500 meters. Meters is very close to a yard. Typically use all three energy systems. The ATP-PC system is used initially at the very start, then a combination of the oxygen system and anaerobic glycolysis powers the middle of the race, and then more emphasis is placed on the anaerobic glycolysis for the kick towards the very end of the race. 2. Most aerobic exercise activities using the oxygen system are fueled by a mixture of carbs and fat. The ratio of fat to carbohydrate utilization is dependent on intensity and duration. Higher intensity exercises utilizes mainly carbs. On the lower intensity side, longer duration exercise utilizes mostly fats. So if you talk to some physical trainers, they'll suggest lower intensity, longer duration to target mainly fat burning. But honestly, high intensity stuff is good for fat burning as well. So it just depends what your training goals really are, and consult a certified person always first. Muscular fatigue is when the muscles no longer have the energy needed to produce a contraction. Muscular fatigue begins when the exercise intensity demands ATP production at a higher rate than the energy systems can supply it. And that's that for the intro. Let's go back. Now let's look at the systems individually. We have the ATP PC. This is fueled by phosphocreatine, or PC. That is a high energy source that is easily broken down without oxygen present. Power. This system can provide ATP at a very rapid rate. The system is the most powerful of the energy systems in the body. Duration. There is enough phosphocreatine stored in skeletal muscle for about 25 seconds of high intensity work. Therefore, the ATP-PC system will last for about 30 seconds, 5 seconds for stored ATP, 25 seconds for phosphocreatine. Activities fueled primarily by this system include most sprint events, weightlifting, shot put, anything where you need a lot of power in a short amount of time. Think ATP, phosphocreatine. So this system is used for quick, powerful bursts of energy, and it's fueled by PC, phosphocreatine, which is stored in the muscles, ready to be used instantaneously. Then there is the anaerobic glycolysis. That is a system that can quickly respond to the demand for ATP, and it doesn't require oxygen to be present as well. Anaerobic glycolysis primarily uses muscle glycogen as a fuel source. Muscle glycogen derives from the carbohydrates that you eat and digest. Anaerobic glycolysis is also referred to as the lactic acid system because the metabolic end product is lactic acid. So at the end of this system converting energy, it builds up a lot of lactic acid. During high intensity exercising, the body produces lactic acid, or lactate is another way to say that, more quickly than the body can utilize it. So it's building up, but your body can't use it as quickly as it's being produced. So it begins to accumulate, and it was once believed that the accumulation of lactate caused fatigue and soreness. However, the accumulation of lactate is actually a beneficial event because lactic acid can be used as an energy source under heavy exercise. And to learn more about lactic acid, there's actually a section in the field trip website. As far as power goes, anaerobic glycolysis is ranked second among the energy systems in terms of power. ATP phosphocreatine system is much more power directed. However, duration-wise, the lactic acid system lasts for about 1 to 2 minutes, whereas the phosphocreatine system lasted about 30 seconds, maybe 25, 30 seconds. This system is ranked second among the energy systems in terms of duration. So this one's like right in the middle of power, right in the middle of duration. Activities fueled by this system include middle distance events like the 400, 600, and 800 meter runs. The anaerobic glycolysis system can quickly provide energy for the body to use because it does not need oxygen to be present. Anaerobic glycolysis is fueled by muscle glycogen, which derives from the carbs and fats that you eat. This system fuels moderate to high intensity activities that last for 1 to 2 minutes. All right. And lastly, we have the oxygen system. Now, this is the only system that requires oxygen. This is the only aerobic system. And it produces the maximum amount of ATP. It can be fueled by carbs, fats, as well as proteins. Fat as a fuel source provides more energy. You get 9 calories per gram than carbohydrates or proteins, which both give us 4 calories per gram. However, fats require more oxygen consumption. So fats produce less energy per liter of oxygen consumed than carbohydrates. The carbs, fats, and the small amounts of protein used by this system during exercise are completely broken down, leaving only carbon dioxide and water as waste products. Maximal oxygen consumption, or VO2 max, is the greatest amount of oxygen your body can consume and utilize. This is a measure of the power of your aerobic energy system. It is generally considered to be the best indicator of aerobic fitness. As your aerobic fitness improves, your body becomes more efficient at consuming and utilizing oxygen. This increase then allows your body to produce ATP faster. The faster your body is able to produce ATP, the more energy you have to work. As far as power goes, the oxygen system is complicated and requires 2 to 3 minutes before it begins producing ATP. Therefore, the initial rate, the starting rate at which ATP is produced, is slow. The oxygen system ranks third among the energy systems in power production. So you don't want to depend on this system for power. However, the duration of the oxygen system to produce ATP is almost unrestricted. The only limitation is the amount of fuel and oxygen available to the cell. So as far as duration goes, it's ranked first in capacity among these energy systems. And the activities where oxygen systems play a role is anything that lasts longer than 2 to 3 minutes, whether it's a sporting event, walking to school, or even playing video games. Your oxygen system is used. It has the lowest power ranking because it takes 2 to 3 minutes before it begins producing ATP. And it's fueled by carbs, fats, and proteins that we consume. It's also able to continue the production of ATP as long as there is fuel, like carbs, fats, and proteins, as well as oxygen availability. Therefore, this energy system is used to fuel every activity that lasts longer than 2 to 3 minutes. So that's a good way to look at things. I'll go back to this main screen. So yeah, the energy systems, this is the most powerful ATP phosphocreatine system, but shortest in duration. Anaerobic glycolysis is middle of the pack for power and duration. And then the least powerful system, but the one that can have the highest duration of ATP production, is the oxygen system. So that's it for 4.3. That is a very short section, but useful and important to know. And if you have any questions, be sure to email me, message me in Canvas, and I'll help you out. But until next time, see you guys and girls. Bye.